Ladies and gentlemen, allow me to introduce this lesson on Euclidean geometry, presenting some of the important facts that you have to know. I have not included all the important facts, but there are some of the important facts that you have to know from grade 10 out to grade 12 in Euclidean geometry. I will present this lesson on the important facts, and I will give you hints on how to approach problem in Euclidean geometry from grade 12 up to grade 12. My name Melule Shabalala. I hope you enjoyed this lesson. Okay, first of all, we have to remind ourselves that failing maths is not an option. And if it was, I was not going to take it. Masicho song sinimabudedi bumnyama uvela ukukhanya kwi-maths. Wow, how nice is mathematics. Okay, what you have to know in FET Euclidean geometry. Okay, first we have parallel lines. We have to know the important facts on the parallel lines, and there is something special about parallel lines. What are something that is important about parallel line? We have what we call alternating angles, we have corresponding angles, and we have co-interior angles. We have to know these facts on parallel lines, and as I move on with this lesson now, I will give you those facts that are those facts. For now, I will list all the important facts that you have to know in Euclidean geometry. We have facts on parallel lines. Parallel lines, we have alternating angles, corresponding angles, and co-interior angles. First of all, okay, wow, how nice. Okay, number 2, we have triangles, and there is something special about triangles. Some of the important things about triangles, we know we have equilateral triangles with all the sides and angles that are equal. And now we have isosceles triangle with 2 sides and equal in length and 2 base angles. You have to know the important facts: equilateral triangle, isosceles triangle, and we have another triangle that we call scalene triangle with 3 sides that are in equal and angles. You have to know that fact. And number 4, we have special type of scalene triangle, that is a right angle triangle. You know, the right angle triangle, it has got 90 degrees as an angle. And there is something that is special about right angle triangle is that it has got 90 degrees as an angle. Wow, how nice. Okay, number 3, we have to know this fact. We have to know the congruent. What is the meaning of congruent? It means that same shape and same size. Same shape and same size. We are talking about congruent, and we have cases of congruent that are triple S. Meaning if they have 2 triangles that have these properties: side, side, and another case of congruent: side, angle, side. In another case, angle, side. In another case, RHS, right angle triangle. We have these cases: triple S, USAS, and RHS, right angled triangle. And we are going to discuss these important cases of congruent. We have to know these 3 things: parallel lines, triangles, and congruent. Okay, let us move on. Wow, how nice. And you have to know, number 4, you have to know properties of quadrilateral. And we know quadrilateral are 4-sided figures. Quadrilateral, you have to know the sequence and be able to prove them. And we have we have a quadrilateral, we have a trapezium, we have a parallelogram, and we have a rectangle, we have a rhombus, we have a square, and we have a kite. We have to know the properties of this quadrilateral in Euclidean geometry. Okay, wow, how nice. Let us move on. Okay, we have to know what we call a midpoint theorem. We have to know the midpoint theorem. Let's say if we have the line joining the midpoint of 2 sides of a triangle is parallel to the 3rd side and equal to the half of the length of the other side. We have to know the midpoint theorem. Wow, how nice is mathematics. Okay, let us move on. We have theorem on cycle. From grade 11, we have what we call theorem on cycle. We have to know the following theorems. We have theorem that say a perpendicular chord and the line from the center of the cycle. We have to know that theorem, and we are going to discuss it as we go on. And we know the equal chord subtend equal angles. You have to know that theorem. And angles subtend at the center and angle at the circumference. You have to know that theorem. You have to know the theorem on diameter, the subtend right angle. You have to know that one. And we have equal tangent. You have to know that theorem. We have theorem on tan theorem. We have to know that theorem. And we have the cyclic quadrilateral with 3 facts. You have to know that cyclic quadrilateral theorem. You have to know this theorem. Okay? Wow, how nice is mathematics. Let us move on. Now, in grade 12, we have what we call the ratios and proportion. You have to know ratios and proportion. And we have 6 cases on similar triangles. You have to know similar triangles. What is the meaning of similar? It means that the same shape, but not necessarily equal in size. We were talking about similar, and usually used to say angle size. We talked about congruent, which is we have to have the same shape and size. But here in similar, we have same shape, but might have different size. Doesn't matter. Okay, that is all about what you have to know. And you have equiangular triangle. This is the only thing that you have to know. You know the important facts on Euclidean geometry. Then we're going to discuss this important fact. Okay, in grade 10 now, what you have to know in grade 10 specifically. Okay, first of all, read that the green one now. They say that quote there, quote from Moses. Moses used to say, I can teach you all the facts, but what is the most important thing is to know how to write down your answers logically. Wow, how nice. We have to know that in Euclidean geometry, you can able to know all the important facts, able to find all the important angles. But what is the most important thing that you have to know? You have to make sure that you are able to write a proof. You have to be able to write proof logically. Don't just get excited for being able to find all the answers. You have to know how to write proof on those theorems. Okay, in grade 10, what you have to know now in grade 10, you have to know the theorem in a grade. You have to know what is the line, theorem on lines. You have to know angles. You have to know congruent. You have to know similarity, what is the meaning of congruent and what is the meaning of similar. Number 1 in grade 10. Number 2, revise theorem on Pythagoras and properties of quadrilateral. You have to know Pythagoras theorem and properties on quadrilateral. And number 3, investigate and make conjectures about the properties of side, angles, diagonals, areas of special triangle, called parallelogram, rectangle, rhombus, square, and trapezium. You have to know those properties on quadrilateral in grade 10. Okay, number 4, we have to know how to call a midpoint theorem. And number 5, you have to be able to apply that midpoint theorem. And the last one, solve problem and prove writers using properties of parallel line, triangles, and quadrilateral. Wow, how nice is mathematics? It means in grade 10, we have to know the properties of parallel lines, and we have to know the properties of triangles, and we have to know the properties of quadrilaterals, and we have to know the midpoint theorem and able to apply the midpoint theorem in grade 10. Wow, how nice is mathematics. Let us move on in grade 11 now. What do you have to know in grade 11? Okay, you have to the revision for grade 10 theorem that we did in grade 10, and investigate and prove the theorem of geometry, the theorems of geometry of cyclic assuming from early grade. It means the main focus in Euclidean geometry for grade 11 is to prove the cyclic theorems on cyclic. You have to know the theorem on cyclic. The main focus in grade 11, it is an addition from grade 10. Well, we know what we did in grade 10. Then what is added now? The theorems on a cycle. What are those theorems? Look at number 3. The line drawn from the center of the cycle perpendicular to a chord. bisect the chord. You have to know that theorem. And number 4, the perpendicular bisector of chord passes through the center of the circle. You have to know that theorem. And number 5, you have an angle at the center of a circle is double the angle at the circumference of the circle. You have to know that one. The angle subtended by the chord of the circle on the same side of the chord are equal. You have to know that one. Number 7, solve circuit geometry problem providing the reason for statement the opposite angles of a cyclic quadrilateral are supplementary. We have to know that theorem. Number 8, you have to know the theorem if the two tangents draw to a circle from the same point outside the circle are equal in length. You have to know that theorem. And number 9, the angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternating segment. You have to know that one. It means in grade 11, you have to know theorems on circle and the work that is done in grade 10, and you're able to provide reasons in those theorems that you are going to do in grade 11. Wow, how nice is mathematics. Let us move on. In grade 12 now, specifically, what we need to know in grade 12 Euclidean geometry. Number 1, we have to know conditions for polygon to be similar, proof, proportionality, and midpoint theorem. We have to know conditions. If I say two things, if I say polygons are similar, we have to know what are we looking at. We have to know those conditions that are we looking at. And number 2, we have to know equiangular triangles are similar. You have to know that if I have two triangles that have equal angles, it means they are similar. Okay, number 3, use the proportionality and midpoint theorem equiangular triangle to prove that equiangular triangle are similar. You have to know proportionality. Use proportionality and midpoint theorem to prove equiangular triangles. We have to know that one in grade 12. Okay, number 4, we have to be able to prove triangles with sides in proportion are similar. We have to know that one. And Pythagoras theorem by similar triangles. We have similar triangles and we have to know how to use a Pythagoras theorem in similar triangles. Wow, interesting. Wow, how nice is mathematics. Number 6, application. Solve problems in 3 dimensions involving trigonometry. I know that you should have done trigonometry in grade 11, in grade 10, 11, and 12. Now we have to apply Euclidean geometry in trigonometry in some of the problems that you have to solve. That is all about that you have to know in grade 11. Now, how nice is mathematics? Let us enjoy this beauty of mathematics. Now, let us move on now because the most important thing in mathematics is to know how to approach certain problems. Let me give you the approach now on how to approach some of the suggested approach to solve Euclidean geometry problem. Okay. Key aspects are proved when solving problem in Euclidean geometry. Most important thing in approaching problem in Euclidean geometry, we have to know before you go to the exam. You have to know the following before you'll be able to solve problem in Euclidean geometry. Number 1, know all the theorem. You have to know the theorem that I discussed above, and you have to be able to know the theorem including their rough sketches. You have to memorize the theorem and their rough sketches, and you have to know all the abbreviation reasoning. Know the theorems and their rough sketches, and know the abbreviated reason, how to reason. If I say the angle at the center is equal to the angle at the circumference, you know how to write the reason for that theorem in short. Okay, bullet number 2, key aspect, what you have to know the properties of triangles. You won't solve problems in Euclidean geometry if you don't know the properties of triangles. You have to know the properties for triangles, and you have to know 4 cases of congruent: side, asa, and SAS, and RHS, triple S, angle, side, angle, and side, angle, side, and right angle triangle. We have to know that one. And now we have what we call suggested approach, and how to approach Euclidean geometry, how to approach problem in Euclidean geometry. Wow, how nice is mathematics. Are you ready for that one? Wow. How nice. We have what you call Dr. Cape Town. We have that doctor now who helped us on how to solve Euclidean geometry in mathematics. Doctor from there in Cape Town, what we call a Dr. Cape Town. We need, as we see that capital letters, we have D, we have R, we have C, we have P, we have T. It means whenever you see a problem in Euclidean geometry, we have to use Dr. Cape Town. Must be there to help you. Dr. Cape Town is there to help you. Whenever you see a problem in Euclidean geometry, remind yourself Dr. Cape Town. Okay. Dr. Cape Town say that whenever we see a problem, we have to look for what? D stand for diameter and R stand for radius. Whenever we see a problem, we're looking for diameter and radius. And we have C there, we're looking for what? So we're looking for what? In C and we P and with C. Okay, let us present that one. Means to the Cape Town, whenever we see a problem, for D, we are looking for diameter. And remember the important fact on the diameter. The fact on the diameter is that diameter subtend the angle, subtend the right angle. You have to know that one. And you have to look for what? Look for a radius now. Wow, how nice. Are you looking for radius? What you actually looking at the radius? You're looking at the tangent perpendicular to the radius. You have to remind yourself that theorem. And don't worry, we will present that theorem. I'll discuss the theorem in this video. You have to present that, know that one. Now let us move on. C now. Wow. What is C stand for? Guess what? Wow. Cyclic quadrilateral. In cyclic quadrilateral, we're looking what? Three things there. Opposite angles are supplementary, means either 280, and the exterior angle equal to the interior opposite angle. And the third one, angles in the same segments are equal. It means whenever they talk about the cyclic quad, we have to remind ourselves immediately those three facts. Okay, wow. P, what is P stand for now? Wow, how nice. Parallel lines. Wow. Parallel lines. What do we have to know in parallel lines? We talked about that in grade 10. You have to know three things on parallel lines. What are those things? Alternating angles that are equally. Corresponding angles that are equally. And co-interior angles that are supplementary. That add up to 180. Wow, how nice. Are you ready for the last one now? Wow. Wow, tangent. T stand for tangent. I mean, whenever you see a Euclidean geometry problem, we have to look for what? Tangent now. And remind ourselves the theorem on tangent, a tan-cont theorem. Okay, basically in Euclidean geometry, specifically for cyclists, now in grade 11, we have to use this thing of Dr. Cape Town that will help us. If they talk about anything based on this one, we have to use Dr. Cape Town to solve problem. Whenever we see a Euclidean geometry problem, we have to use Dr. Cape Town. We are looking for diameter, we are looking for a radius, we are looking for the cyclic quad, and we are looking for parallel lines, and we are looking for what? Tangent. Then we have to solve problem on Euclidean geometry. Wow, how nice. Ladies and gentlemen, allow me to present or to do an example based on Dr. Cape Town there. Wow, how nice. Okay, let's look at this one. They say if OT is a radius and AB is a tangent, find the unknown angles given reasoning for your answer. If you can see now, they say if OT is a radius, wow, Dr. Cape Town, we have R then, Dr. Cape Town. What R stand for? Radius. Immediately you can see, remind yourself theorem in radius. What are those theorem in radius? You know, we have, if the radius is perpendicular to the tangent, we know that we have a 90 degrees angle. Before you solve the problem, we know that. And they say AB is a tangent. Wow. Dr. Cape Town, we have T then, Dr. Cape Town. They talk about tangent. What do we have to know on tangent? We have to know the tan-cont theorem. Wow. Before you solve problem, okay, they say find the unknown angles given reason for your answer. We have this thing, our diagram there. We have our tangent and there is something about special about tangent, then Dr. Captain, we have to remind ourselves that thing, and we have radius, all those things. Okay, now we talked about radius. What do we know about the radius? Remind yourself from Dr. Captain. We talk about radius. They say in radius we're looking for, they say tangent is perpendicular to the radius. What tangent do we have there? They talked about tangent OT. This one, we have a tangent OT. This is our tangent. And this is our radius OT. And they talked about what? Tangent. What is our tangent there? We have our tangent AB there. We have our tangent AB. And they say radius, tangent perpendicular to the radius. It means if we have our radius OT and we have our tangent AT, they say it means here we have an angle that is perpendicular there. Wow. It means that angle equal to 90. Before we solve problems, okay, now in triangle OTB, we have a triangle there. We have our 90 degrees at T and we have our 36 degrees at B. What we know now, what can we find our x now? You see there is a triangle there. We have two angles. What is the angles in a triangle? They add up to 108. It means if I want to find x, how can I find x? I can say 180 minus these two angles and get what? My x. Wow, how nice is mathematics? Let's enjoy the beauty of mathematics. Can you see now from here up to here? We have what? A diameter there. Wow, we hear something about diameter in Dr. Captain. D. What do we know about diameter? We know that diameter subtended an angle of 90 degrees. We have our diameter and we have our angle that is 90 degrees. It means there my y there equal to what? 90 degrees. How nice. Now I have my y equal to 90 degrees. I have that one equal to 30 degrees. How can I find z? Wow, interesting. Even now I know that this is my triangle and I can get the z there. How can I get z there? It's 180 minus that 30 plus that 90 and got my z there. Wow, what can we conclude about this angle now? Because we have our chord there and we have our tangent there. What do you know about the theorem? Tan-chord theorem. If we have an angle between the tangent and the chord, this angle equals the angle that the alternating segment. What segment? What chord are we talking about? Are we talking about this chord? The angle between this chord and the tangent. It means now I have from this chord, below this chord. Let me move now up until there. Oh, now I got this 30 degrees. It means the angle in the alternating segment, it is 30 degrees and equal to what? To that one of 30 degrees. Now, let's answer the question. They say, find the unknown angles. Wow, how nice. Okay. Oh, they find our unknown angles, x and y and z. We talked about x. Then they say, find our angle. We know that when you find the x, it is x is there. We got that one 90 degrees and that one 36 degrees we talked about. And you know that angle is in a triangle up to 108, and I can say 180 minus the sum of these two angles that I got my angle x equal to 54. The reasoning for that, they say give you the reason for that Tan-chord theorem, an angle sum in a triangle. Okay, now they say find your y now. I know the y, I have my tangent there. From here up to here, it means that angle equal to what? Equals to 90 degrees. You know that angle equal to 90 degrees. The reason angle in a semicircle. And z now. How to find z? I know I have that angle equal to 90 degrees. And I have that one that equal to 30 degrees. And this is a triangle. I can say 180 minus this, the sum of these two angles. And I got my angle there, of which is 60 degrees. Wow, how nice is mathematics. Let us enjoy the beauty of mathematics. Let us move on now. Okay, how to prove the following now. Give you a hint now on how to approach problem. How to prove the following. How to prove that lines are parallel. Okay, we use this thing to use two things. If they say prove that if two lines are parallel, then the corresponding angles are equal, okay? Or alternating angles are equal or co-interior are equal. You can use anyone between this one to prove that line are parallel. It means if they say line are parallel, we can use this thing to prove that lines are parallel. Okay, now let's just move on. If they say prove that quadrilateral is cyclic, what are we looking at? And I told you that to prove cyclic quadrilateral, we are looking for three things. What are those three things there? Prove that cyclic is a cyclic quadrilateral, we have to know that three things. If quadrilateral is a cyclic quadrilateral, then opposite angles are supplementary. Number two, if a quadrilateral is a cyclic quadrilateral, then the angles in the same segment are equal. And if a quadrilateral is cyclic, then the exterior angle is equal to the interior opposite. We can use anyone between these three things to prove that a quadrilateral is cyclic quadrilateral. Wow, how nice. Let us move on. If they say prove the line is a tangent, what do you know about that one? How to prove that a line is tangent? Okay, we know these two things. If the line is a tangent, then the angle between the line and the chord is equal to the angle subtended by the chord in the alternating segment. Okay, first that one. Number two, we can use that one. They say if the line is a tangent, then that line is perpendicular to a razor. You can use that one. It means if they say prove that line is a tangent, you can use anyone between these two things to prove that it is a quadrilateral. You can choose this one. Well, this one is certified. You can conclude that that line is a tangent. Wow, how nice. Let's just move on. Okay, we have what we call the diameter. If they say prove the line is a diameter, how do you have to know in the diameter? If they say prove the line is a diameter, we are looking for this fact. If the line is a diameter, then the angle subtended by the line on the circumference is right angle, then equal to 90 degrees. You know that theorem on diameter. If they say prove that line is a diameter, we have to show that the angle subtended by the line on the circumference is a right angle. Wow, how nice. Let's just move on. Now, how to prove that two triangles are congruent. We talked about the congruent triangle that have same shape and size. What do you have to know? I've talked about 4 cases of congruent. It means if they say prove that two triangles are congruent, we're looking for that one. Prove from any of the cases of congruent. We can use the case number 1. If they say side, if you have two triangles that have same sides, if you have side, or angle, side, angle, or side, angle, side, or RHS, right angles, right hypotenuse, and side. You have to know this thing. They say prove that triangles are congruent. We can use anyone between these 4 cases of congruent triangles. Number 2, if they say prove that two triangles are similar, what do we have to show? If they say prove that triangles are similar, then you have to use this thing. If they say prove triangles are similar, we can use. If they say two triangles are similar, then prove that all angles are equal. If two triangles are similar, then they have got equal angles. And if they can say prove that two triangles are equal, then sides are in proportion. Means we are looking at if all triangles are equal, it means the triangles are similar. And if they say sides are in proportion, that triangles are similar. That's the most important thing on how to approach there. Okay, now we have to know the parallel lines. We have parallel lines, as you can see that we have this line go there and that line go there. These two lines are parallel, and we have to know facts on the parallel lines that we talked about: alternating angles, corresponding angles, and co-interior angles. Okay, let's just go on. We have what we call alternating angles. They form Z shape. We have, they say C equals to F. C equals to F. Alternating angle, they form Z shape. We can see, our Z, and we can Z. We have our angle F there, and we have our angle C there. They are alternating angles. And D equals to E. Alternating angles, D equals to E. This is our D, this is our E. D equals to E. alternating angles, they form what? Z shape. Wow, how nice. Let's look at another important fact. We have what we called corresponding angles. Corresponding angles usually form what? F shape. They say corresponding angles are equal, and alternating angles, there we said alternating angles are equal, and here also corresponding angles are equal. They say there A equals to E. We have our A equals to E. Now we have this A equal to E. Corresponding angles are equal. They form F shape. You can see here, and we have F shape. A equals to E. And other alternating angles, B equals to F. We have our B equals to F. They are corresponding angles. They have C equals to G. We have C equals to G, corresponding angles, and we have D equal to H. We have D, our D equal to H, corresponding angles. Then the last fact on parallel lines, we have co-interior angles. They say co-interior angles are supplemental. It means add up to 108. Then they form a C shape. For corresponding angles, we have C and E. Corresponding angles C and C, they form C shape, and they add up to 100. It means if I add C and E, and I get 108. D plus F. Now we have D and F. We have D and F. I got what? 180 degrees there. Now, what you have to know that now, if two lines, okay, if two lines are not parallel, we can still find the alternating angles. If two lines, it means if you have two lines, these are not exactly parallel, but we can find two. We have to find two alternating angles and corresponding angles, but in that case, we know that alternating angles, we've got unequal alternating angles if we have two lines that are not parallel. It means if we like two lines that are approaching each other there, we know that we have that two lines are not parallel as such, but look like they are parallel but not parallel. We can find alternating angles and corresponding angles that are not equal. Wow, how nice. I hope it is clear now in the parallel line. Let's just move on. We have triangles, congruent. We have congruent in the triangles, and we have to know that cases of congruent. Case number one, side, side, side. They have two triangles. If there's two triangles equal sides, it means they are congruent. If this triangle have this side equal to that side, and in this triangle you see we have that side equal to that side, and we have this side equal to that side. It means three sides are equal. This side is three sides, and this side three sides. It means case number one, triple side, 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 side. Okay. Case number two, side, angle, side. You have side, angle, side, side, angle, side. In this triangle, I have this side, and I have this side in this one, and I have this angle, and I have this angle, and I have this side, and I have this side. It means this case, side, angle, side. Case number two for congruent. Case number three, say angle, side, angle. Means I have my angle in this triangle equal to that angle in that triangle. Have this side equal to that side, and I have this angle equal to this angle. That's why I have angle, side, angle. Wow, how nice. Case number four, I have angle, angle, side. In this triangle, I have this angle, and the triangle, I have this angle, and I have this angle in this one, and I have this angle in this one, and I have side in this one, and I have side this one. That's why I said that case is angle, angle, side. Those are the four cases of congruent that you have to know in Euclidean geometry. Okay, note that the case of side of angle, angle, angle cannot be used to prove congruent, because we might have triangles that have same angles, but they are not equal in shape. So inside they might be equal in shape but not equal in shape, because we have equilateral triangles that are exactly the same but not equal. I have equilateral triangle that have maybe side that are equal 5 centimeters, 5 centimeters, 5 centimeters. They have all equal angles. At some point I might have equilateral triangle that have side that have 10, 10, 10, but they have equal angles but they are not congruent, because congruent means that two shapes must have the same side and same shape, because we have see here same size and same shape. That means that's what we talk about the congruent. Okay, let us move on now. We have what you called a midpoint theorem in grade 11. What's the midpoint theorem? They say the line joining the midpoints of two sides of a triangle is parallel to the third side and equal to the half of the length of the other side. It means if I have this line joining the midpoints of this line and midpoint of this line, because this distance from here to here equal, and here to here equal to that one, it is the midpoint for this line AB, and here it is the midpoint for BC. The midpoint theorem, if I have this line joining the midpoints for these two lines, it means this line, it is parallel to the third one, and this line, if I want to find AC, it is 2 times that one. That is what we talk about the midpoint theorem. Wow, how nice. Triangles. So type of triangles, we have to know in Euclidean geometry, we have to understand the properties of triangles as well as important facts. Here are some of the properties of triangle that we have to know. We have to remind ourselves equilateral triangle. Triangles have equal angles and equal sides. Okay, and we have isosceles triangle that have base angles are equal and two sides there are equal there. And we have isosceles scalene triangle that we have all sides are not equal and angles are not equal. And we have a right angle triangle that have 90 degrees or have right angle there. Okay, important fact that you have to remember in triangles. What you have to remember in triangle? Okay, wow, how nice is mathematics? 1, sum of the interior angle is equal to 108. In a triangle, if you have triangle angles in a triangle, they know that they add up to 180. Wow. Then the exterior angle is equal to the sum of the interior opposite angles in a triangle. That one. Let's say the exterior angle is equal to the sum of the interior opposite. We have this thing, this D there, exterior angle. They say it's equal to what? The sum of the interior opposite. The interior, we have this one, A and B, the interior. It means if I add A and B, they both equal to what? D. That's why there I say D equal to A plus B. There, that's the theorem. They say the exterior angle, of which is D, is equal to the sum of the interior opposite angle. The interior opposite angles are A and B. That's why they're talking about the sum of the interior angles equals to the exterior angle there. That is the most important thing that you have to know in triangles. Okay? We have now what we call cyclic theorem in grade 11. What you know, we have to know in cycles now. Okay? We have to, first of all, we have to remind ourselves part of the cycle. This is our cycle. What you call, we have the circumference. The circumference of, you have what you call the circumference. We have this line, what you call that line is a diameter, and we have that line, what you call the radius, and we have cycle, and we have this line, what you call this line. The diameter is from divide the center, the triangle, the circle into 2 equal halves, but we have a chord. The chord, it is a line that divides the circle into 2 segments, minor segment and major segment. It means that line, what do we call that line? It is a chord, and we have the major segment, the bigger part of the circle, and the smallest part that we call minor segment. And we have and minor arc there in the major segment, and minor arc there. We have a major arc there in a major segment, and we have a minor arc there in a minor segment. Then we have a cycle there. We have 2, this is what we call radii, because it is the radius and it is a radius there. Okay, we have minor sector and we have major sector. What do we call that line? This one, the red one, what do we call that one? The line that touches the circle once, and we also have that line touches the circle once, and also have that line touches the circle. What do we call that line? We call the tangent. We have to know this thing first, and then you get in geometry. Okay, let us move on now. What we call the cyclic theorem. Theorems in cyclic. Theorem, the one that you have to know in cyclic. The angle in the semicircle equal to 90. It means the diameter subtend the angle that is equal to 90 in the circumference. Wow, how nice. Let us move on. Number 2. They have the theorem that say angle at the center is 2 times the angle at the circumference. We see angle at the circumference, which is 60. and this angle, which is 2 times the angle of the circumference. That's why if I say I have 60, here it means I'm going to have 60 multiplied by 2, it means 120. That is the theorem that you have to remember. And we have another theorem. They say angles in the same segment from common chords are equal. It means if the angles are subtended by the same chord are equal. I have this chord subtended the angle at the circumference, and the very same chord subtended the angle at the circumference. That's why we have angles there that are equal. Wow, how nice. Let's just move on. We have what we called the cyclic quadrilateral. And remember, I said we have to remind ourselves 3 things in cyclic quadrilateral. First of all, they say the opposite angles in cyclic quadrilateral always add up to 108. You mean the opposite angles. I have this one opposite to that one. I have 100 and I have 80 there. It means 100 plus 8, they add up to 108 opposite angles in a cyclic quad. And there I have 70 and I have 110 there. If I add these 2 angles and I got what? 108 the angles in a cyclic quadrilateral. Wow, how nice. Number 5, the angle between the radius and the tangent. You know the angle between our radius, we have our radius and we have our tangent. The angle between the radius and tangent equal to what? 90 degrees. And we have this theorem, what we call the tan chord theorem. They say the angle between the tangent, between the chord and the tangent is equal to the opposite angle inside a triangle alternating segment. It means here I have my tangent there, here is my tangent, and this one, it is my chord. The angle between the tangent and the chord equal to the angle in the alternating segment. Let's look at this one. I have my 70 between this chord, the red one. It means now let me now move here from this chord up until then alternating segment. It means this thing equal to what? 70. And I have this angle 60 between this tangent, this chord and this tangent. Now I have this angle between this tangent. Let me move now to this one now. It means alternating segment. That's why I have what? 60 there. The angle between the tan chord theorem, this angle between the tangent equal to the angle in the alternating segment, that one. And the angle between the chord and the tangent, this one, equal to the alternating segment, that one. That's why we have 60 there. We have to know that theorem. Let's say if we have the tangent to a circle from the same point will be equal. It means we have 2 tangents that are coming from the same point, then meet at C. It means these two tangents are equal. You have to know that theorem. And the last one now, the radius through the midpoint of the chord bisects the chord. Wow, we have the chord, that one. If we have a line from, is it then coming from, if we have a radius here from the center to it will bisect that chord or form an angle of 90 degrees perpendicular. That we have to remind ourselves that theorem. That is all about theorem on cyclic quadrilateral, and we have to be able to apply those theorem. Okay, let's just move on in grade 12 now in proportion. They say if 2 triangles are equiangular, then corresponding sides are in proportion. We have to know that if we have 2 triangles, it means triangle that are equiangular. This triangle have x angle there. It means if they say equiangular, each has got same angle. We have this angle and we have this angle, and this angle equal to this angle, this angle equal to this angle, means they are in proportion. If I can take AB divided by DE might be equals to AC divided by DF, or BC, this side BC divided by what? If this side are in proportion. Another one now, then if triangles or parallelogram are on the same base or base of equal length and between the same parallel lines, then triangles have equal areas. I mean, if I have 2 triangles in this one, I have this triangle from here ACD and triangle CBD. If I have 2 triangles that are between 2 parallel lines, it means they have equal area. It means the area of triangle ACD, it is equal to the area of what? Triangle BCD. Why? Because they are between the parallel lines. And what we know that we know that they have equal bases. They share the same base. To which it C D, and they have equal edge because the height between this one and this one, because they're between parallel line, the height here, it is the same as height here, the same as the height here. It means they have the same height and they're sharing the same base. We know that the area of a triangle, half base multiplied by height. They have the same base, half base, and they say the same height. They have height. That's why they have equal areas. You have to know that. And the last one now, the midpoint theorem, and we discussed that one. The midpoint theorem, that you have to know the line segment joining the midpoints of two sides of a triangle is parallel to the third side of an equilateral triangle. We have to know that one. Okay, now the important cases of similar triangles in grade 12. We have 6 important cases. The case number 1, you discuss that one of a similar triangle. We have cases that similar triangles mean triangle ABC is similar to triangle CDE. How? It means we know that we have two parallel lines and we have B equal to E1. Why? They are corresponding angles. And we have A equal to D and their corresponding angles. And we have C common side. It means triangle, we have the same angle C. We have triangle, we have angle A, D. In this triangle A is A, B, D. I have that angle, and here I have that angle, and here I have that angle, and I have that angle, and this one is common angle. That's why I can say triangle A, B, C. It is similar to triangle D, E, C. Case number 1. Number 2, if I have this thing, the triangles. If I have this one, triangles that are similar. In this case I'm looking at, it means triangle PTQ, similar to the triangle, that one RST, similar triangle. How? Okay, if you can see, have to see that